Educational GMAT. Your partner in your GMAT journey.
Very tricky question. I'm going to take some time on this. Go through the question, and then we'll actually look at the data that's presented in the Excel spreadsheet. So 25 students enrolled in an economics class, and that data is in this Excel that I'm going to open up shortly. Now look at this. The final score was computed as a weighted mean of the scores on exam 1, exam 2, and the final exam, using the same weights for each student. So let me quickly open the Excel for you guys. So this is the data for 25 students. So whether that student is online, an online student, which year is that student in, exam 1 score, exam 2 score, final exam score, and final score. Now, notice what the question is mentioning is that this final score that is calculated, how is it calculated? As a weighted mean of exam 1 score, exam 2 score, and final exam score. Weighted mean. Now, mind you, just to make sure, if final score was to be calculated as just the average of these three, then obviously it would have been easy. For example, for the first candidate, how would you calculate that? 65 plus 70 plus 68 divided by 3, right? That would have been the average. But in this case, it's not a simple average. The question says it's a weighted mean. What weighted mean means is that different weightages are assigned to each of the three exams. For example, final exam maybe carries a higher weightage, correct? So that is what weighted mean means. Now let's go back to the question. The question is asking us this. Oops, sorry. The score on the final exam had equal weightage with the score on exam 2. Remember, there are three exams, right? There are three exams. Exam 1, exam 2, and final exam, right? Final exam. And then there is a final score, right? And this final score is calculated based upon the weighted mean of these three exams. So the question is asking us, this statement is asking us whether the score on the final exam, had equal weightage with the score on exam 2. Did these two exams have equal weightage? That's what the question is asking us. Okay, now let's first quickly kind of go through the concept of weighted average. Let's go through the concept of weighted average. Suppose that uh, let's say there are a class has 100 students, some girls, some boys, and let's say girls had let's say there are uh, I'm taking extreme here so that the concept is clear. Let's say there are 49 girls and one boy in the class. All right. Now the average score of girls, average score of girls is, let's say, 75 score out of 100. And the average score of boys is 100. Now, obviously, there is just one boy, so which means that boy got 100, right? So, did you get this scenario? There are total of 50 students in the class. Out of those 50 students, 49 are girls and one boy. The On a maths exam, let's say maths exam, on a maths exam, the average of these 49 girls is 75, and there is a single boy who had 100. Correct? So now can you tell me what will be the average of the entire? First of all, in fact, let's actually slightly modify this so that things are slightly clearer. Let's slightly modify this. Let's take 80 as the average. Before that, suppose that there were 25 girls and 25 boys. Now, again, I'm taking it, retaining the same statistics. Let us say the average score in mathematics for 25 girls is 80, and the average score in mathematics for 25 boys is 100, which, by the way, in this case means that every boy got 100. So in this case, in this scenario, can you tell me what would have been the average of the entire class? What would have been the average of the entire class? Entire class means 50 students in this particular case. Notice, since there are same number, very nice. Since there are same number of girls and boys, the weighted average or the average of the entire class would have been smack in the middle, right? Between 80 and 100, which is 90, because there were equal number of girls and boys. Got me? Are we clear? Right? Same number of girls and boys. So the average would have been right in the middle. Now let's come to this case. There are 49 girls and only one boy. Girls had an average of 80, boys had an average of 100. As we discussed here, had they been same number of boys and girls, then the average of the entire class would have been 90. Right? But in this case, since there are more number, in fact, much more number of girls than boys, the average of the class would be what? Would it be tilted more towards girls or more towards boy? More towards boys. Clearly, yes. Can someone tell me the average of the entire class, would it be tilted more towards girls or more towards boys? Clearly, very nice, Dhanush. Clearly, it will be tilted more towards girls, right? Because in fact, it will be heavily tilted towards girls because there are more number of girls in the class. That would be the weighted average of the entire class, right? Okay. One last thing before we return back to the question. One last thing before we return back to the question. Let us say, again, going ahead with the same scenario, 49 girls and one, oops, 49 girls and one boy. All right. The average of the girls, average maths score for the girls in the exam is 80. And this boy also scored an 80. All right. If this is the case, then can you tell me what would be the average of the entire class? Then what would be the average of the entire class? Absolutely. The average of this class in this case would be 80. Then it doesn't matter how many girls and boys are there, right? Because average of girls is also 80, average of boys is also 80, so it doesn't matter how many girls versus boys. The average of the class would also be 80. So are we clear with these concepts? Now let's return back. Now let's return back to this question. We have to find out whether in calculating the final score, whether exam 2 and final exam had the same weightages, Now, I'm going to present you with a scenario. Think about this. Think about this. Suppose that, now this is going to be slightly tough, guys. Suppose that there are we have a data for 25 students, correct? Out of these 25 students, think about it. If I'm able to find a student, so the student has an exam 2 score and a final exam score, right? Now think about it. Suppose that exam 2 and final exam had the same weightages, right? This is the question we have to answer, by the way. Do exam 2 and final exam have the same weightages? Let us say if exam 2 and final exam have the same weightages, then do you agree that any person's weighted average in these two exams would be smack in the middle? Agreed? See, this goes back to what we discussed on the earlier slide, right? What did we discuss on the earlier slide? What we discussed on the earlier slide, just keep in mind that, right? That if there are 25 girls and 25 boys, girls had an average of 80, boys had an average of 100, then the average of the entire class would be smack in the middle. Why? Why is it smack in the middle? Because girls had the same weightage as boys, because number of girls is the same as number of boys. Similarly here, since if exam 2 has the same weightage as final exam, then any person's average in these two exams would be smack in the middle, the way it was smack in the middle here, right? So the average would be smack in the middle, correct? Now here is the trick. Here is the trick. So this is the average of the candidate in these two exams, right? Now think about it, guys. This is the slightly difficult part. For this person, if this person's exam 1 score is also equal to this, all right? If this person's exam 1 score is also equal to this person's average score in these two exams, then do you agree that this person's final exam score would also be this? Now, this is important, guys. This is important. Take some time. This person's average in these two exams is smack in the middle. Why is it smack in the middle, by the way? Assuming that exam 2 and final exam have the same weightage, right? Assuming that exam 2 and final exam have the same weightage, this person's average score would be in the middle. And if this person's exam 1 score is also the same as the average score, then this person's final score would be this. It doesn't matter in that case what the weightage of exam 1 is. It doesn't matter. Now, why does it not matter? We discussed this as well. We discussed this as well. If you remember, what we discussed was, again, the boy girl thing, right? Let's say girls are 49 and boys just 1. If girls have an average math score of 80, boy also has an average score of 80, then the average of the entire class would be 80. Correct? In other words, right? In other words, if the scores that they are getting the same, the average scores that they are getting is the same, then the number of girls versus number of boys does not matter. In other words, the weightage of girls versus boys does not matter. Whether it is 49-1 or whether it is whatever. In fact, let's reverse this. Whether we have only one girl in the class and 49 boys in the class or any combination, the average of the class would still be 80. So in this case, the weightage, individual weightages does not matter, do not matter. Correct? Similarly here, same analogy. If exam one score is the same as the average score, notice this score was the same as this score. If exam one score is the same as the average score, then it doesn't matter what the weightage of this is. Irrespective of whatever the weightage is, the final score would be the same as the average score. This is a slightly tricky concept to understand, but I'm hoping you get it. So now what we are looking for is when we open the Excel, out of the 25 students whose data is presented, we would look for a student whose exam one score is exactly in the middle of that candidate's score in exam 2 and final exam. And for that particular candidate, if that candidate's final score is also the same as this score, then we know that exam 2 and final exam have the same weightages. Do you get it? Because this is something that we were able to arrive at, assuming that exam 2 and final exam have the same weightages. Again, reiterating from the data, what will we look at? We will try to find out a student whose exam 1 score is midway between exam 2 and final exam score. And for that particular candidate, if that candidate's final score is also the same as this score, then we know that exam 2 and final exam have the same weightages. All right. So now let's open the Excel. Let's open the Excel. So now let's look at this. Let's look at the first candidate. Notice exam 2 score is 70, final exam score is 68, right? So we were looking for a candidate whose exam 1 score should be midway between the two, right? It should have been 69. So this is not 69, so let's skip this. Similarly here, notice 75 and 71. So we were expecting this to be 73. So this also doesn't qualify. Now I am going forward with this. Notice this. Notice pi. Notice pi. Pi is exam 2 score and final exam score are 78 and 72 respectively. So the average, right, had exam 2 and if exam 2 and final exam have the same weightages, then the average of these two would have been 75, correct? And notice this candidate's exam 1 score is also 75. So had exam 2 and final exam score had the same weightages, then we would have expected this candidate's final score to be 75. Just going by the theory that we just discussed, right? So however, we notice that this candidate's final score is not 75, it is 74.25, which clearly means that exam 2 and final exam do not have the same weightages. So a lot of theory behind this, but I'm hoping that this elaborate explanation helped clear a lot of things, especially with respect to weighted averages, because weighted averages is a concept that will get tested not only in data insights, but also in quant. All right. So the answer would be no. The others are easy, by the way, here. The others are easy. So Okay. So this answer is obviously no. Now, median final score for all 25 students is 81.5. Median is obviously the middle value when you arrange the data in ascending sequence. In this case, you would arrange the data in ascending sequence for final score. So you would sort it on final score. And since we are talking about median, in this case, we would find out the 13th value, right? The middle value, which would be 13th in this case, when the data are arranged in ascending sequence. So final score is basically column G. So we sort on this, and once we sort it, it's been sorted. Now we find out the 13th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th. So 13th value is how much? 81.5. And that is exactly the figure that is given to us, right? That's exactly the figure that is given to us. That the median final score is 81.5. So this is definitely correct. And finally, exam one scores for students in year 3 of the program. For exam one scores in year 3 of the program, the range was 40. By the way, range is what? Range in a data set is always maximum value minus minimum value. That is how range is defined. So exam one scores year 3. Let's go back to the Excel. Exam one scores year 3. So exam one scores year 3. So we will first sort by the year, right? Once we sort by year, we scroll down and come to year 3, right? And mind you, these are the exam one scores. So year 3, if you look at year 3, from here to here, what is the minimum score? Minimum exam one score? 51. And what is the maximum exam one score? 91. So again, as I said, range is always maximum value minus minimum value. In this case, it would be 91 minus 51, which is 40. And that's exactly what the statement also mentions. So the range was 40 is also correct. Are we clear, guys? All right. Slightly, this is quite a tricky, heavy duty question, I would say, with respect to the weighted means.